For scientists studying the sun, nothing is more predictable than its noise. Even from 150 million kilometers away, our star crackles with constant activity. Solar winds, radiation bursts, magnetic storms. It hums, roars, and pulses in ways humanity has studied for decades. But on May 12, 2020, something happened that should have been impossible. The sun went quiet. It began with a routine observation at the Solar Dynamics Laboratory. A group of researchers monitoring solar oscillations noticed something unusual. Several sensors flatlined, not malfunctioning, just silent. The sun's usual vibrations had weakened dramatically, almost fading into stillness. At first, they assumed a software glitch. But then, other observatories around the world reported the same thing. Seismic signatures from the sun, the rhythmic pulses emitted by plasma waves, had dropped by nearly 70%. The sun was still shining, still burning, but its heartbeat was slowing. Solar physicist Dr. Helena Kirov was one of the first to sound the alarm. She described the readings as the quietest the sun has been in recorded history. Normally, low activity indicates the start of a solar minimum, but this was far beyond any known cycle. It was as if the sun had suddenly lost its internal rhythm. But the strangest part? Earth reacted. Within hours, magnetometers around the globe detected an unusual calm in the planet's magnetic field. The solar wind, which normally slams into Earth's magnetosphere, had weakened sharply. The constant invisible pressure our planet is accustomed to simply stopped. Air pressure shifted slightly. Birds across several regions changed flight patterns. Northern lights faded days earlier than expected. Satellite operators reported abnormally stable orbits, as if the invisible hand that constantly nudged them had let go. The world didn't notice, but scientists did. Then the silence deepened. 2 days after the initial anomaly, something even stranger occurred. The sun's surface developed a faint, symmetrical pattern, almost like ripples across water. Dark bands formed and moved in unison, unlike anything recorded before. These solar waves traveled too slowly to be convection, too smoothly to be turbulence, too organized to be natural randomness. Dr. Kirov later said, "It was like the sun was whispering in a language we didn't understand." As the ripples spread, solar observatories detected a faint oscillation, like a low-frequency drone. Not radio noise, not interference. A sound pattern created by plasma shifting deep inside the star. Something was happening beneath the surface. And then, just as suddenly as it began, the sun emitted a small, localized flare. Tiny, too weak to reach Earth. But it wasn't the flare that shocked scientists. It was the shape. The flare bent sharply as it erupted, forming a crescent rather than a burst, as though magnetic lines redirected it unnaturally. Something inside the sun was guiding the energy. For a brief moment, the sun behaved like a machine, or like something responding to an internal structure we have never detected. Observatories worldwide captured the event. None could explain it. Then came the blackout. On May 20th, 8 days after the first anomaly, all solar readings suddenly dropped to absolute zero. Every satellite, every telescope, every sensor. The sun was shining normally, but every instrument pointed at it saw nothing. It was as if the sun had become invisible to the machines designed to study it. This lasted exactly 11 minutes. During those 11 minutes, power grids across Europe reported subtle, synchronized fluctuations, too small to disrupt, too strange to ignore. Deep-sea sensors registered a faint global vibration, and several airline pilots reported seeing a brief, unnatural shimmer in the upper atmosphere. Then, just like that, the sun returned. All data streams normalized. Solar winds resumed. The magnetic field stabilized. And the sun's internal oscillations, the heartbeat that had gone silent, came back stronger than before. Scientists were left stunned. The official explanation? An extreme solar minimum irregularity. But privately, researchers admitted they had no idea what happened. Some believed a massive subsurface magnetic reconfiguration temporarily changed the sun's behavior. Others suggested a rare plasma inversion event, something never recorded but theoretically possible. Yet the strangest theory came from a small group of astrophysicists studying the solar core. They proposed that the sun experienced a temporary phase shift, a moment where internal plasma synchronized, creating perfect destructive interference, silencing the sun's internal vibrations, a cosmic heartbeat stopping, then restarting. But there was one more detail that never reached the public. During the 11-minute blackout, one radio telescope in Western Australia captured a single repeating signal coming from the sun. 3 pulses, perfectly spaced, perfectly identical. Artificial? Natural? A glitch? No one knows. The data was archived and classified. Since that day, the sun has behaved mostly normally, a little quieter, a little more stable. But solar physicists now monitor it with a new kind of attention, watching for patterns, ripples, or any sign of another silence. Because stars don't just change their heartbeat, not in minutes, not in days, not without reason. And if the sun can go silent once, it can do it again.